Hi boys and girls, welcome to another math class. Today we are going to look at the chapter called Basic Geometry. You can find it in your all-in-one book as the chapter name Basic Geometry. Now, what are you going to learn today? We are going to look at various things, okay? And it's going to be fun. So I want you to have your notebook also along with you so that anything you learn, you can make a note of it and you can practice as well. We're going to learn about what a point is, what a ray is, what is a line segment, what is a line, what is an angle, and I'm going to introduce you to the geometry box. Alright, after that, I'm going to show you how you can measure a line segment with the ruler from the geometry box. And we're also going to look at what a square, triangle, rectangle, and a circle is. So, quite a few things to learn in this chapter. But I promise you, it's going to be fun, and this is super important concept for you. Even as you grow big, you're going to find geometry to be one of the most important concepts of math. So I want you to pay close attention to what I'm teaching, and I want you to pause the video if you want to understand a little more, and you can rewind, you can play it again until you're clear about all the concepts of geometry. Alright, I hope you're ready and I hope you're excited. I hope you have your textbook and your notebook and your pencil with you. Let's get started. Okay, let's start with a point. Okay, so what is a point? P, Q, R. A point is a mark of position. Okay, so it is represented by a dot. As I represented here, it is just represented by a dot. It is named with a single capital letter. As you can see, I have named the points as P, Q, and R. And you can also observe that a point has no length or breadth. Alright? So, this is read as point P. And this is read as point R. And this is read as point Q. So, it's just a mark of position. It is represented by a dot. It is named with a single capital letter and it has no length or breadth, and it is read as point P or point R or point Q. Now, what is a line? A line always means a straight line, alright? And it is a set of points. It is not just one point, but it is a set of points. As you can see, this is a straight line and it has a set of points. Now, a line can be extended indefinitely in both directions. That means it can be extended in this direction indefinitely and in this direction indefinitely. And it is named with two capital letters. For example, let's take this line. Is extended indefinitely that side, indefinitely this side. I name the 2 points as A, B. So, it is named with two capital letters. Alright, it can be A, B, P, Q, anything. Alright. Now, as you can see, this is another line. This line is it's named with PQ. Alright. So, line PQ and line AB can be extended in both directions. Okay. That's why it is denoted by, how do you denote a line? You denote a line. This is the symbol AB and arrows in both direction. PQ and arrows in both directions. That means it can be extended in both directions. As you can see, a line has length, but it has no width. Remember, point has no length and no width, but a line has length, but no width. So this is a line. Now let's look at line segment. We finished point, we finished line, now we come to line segment. What is a line segment? Now, a line segment is part of a line. That means it is part of a line and it also has a starting point and an ending point. Remember, line has no starting and ending point. It can extend indefinitely in both directions, but line segment has a starting point and an ending point. All right. Now, it is also the shortest distance between 2 points. All right. It has a definite length. Can you see it has a definite length? But it has got no width. And it is named with 2 capital letters. As you can see, we named it with 2 capital letters, C and D. You can have another line segment and you can name with MN. This is another line segment. What is the symbol? How do you write a line segment? This is the symbol, MN or CD. All right. As you can see, because it is having a starting and ending point, we just put it like this. We don't put arrows on the either sides. Now, a sleeping line, all right, a sleeping line is called a horizontal line. As you can see, this is a horizontal line. And a standing line is called a vertical line, all right. And then a line slanted to one side like this. This is called a slanting line. So you have the horizontal line, which is a sleeping line. You have the standing line, which is called the vertical line. And then you have the slanted to one side, that's called a slanting line. Okay, now let's look at a ray. What is a ray? Now, ray is nothing but a line starting from a point and extending indefinitely in one direction. Only in one direction it extends indefinitely. So it is starting from a point E and it's extending indefinitely in one direction. And the symbol for ray is, can you guess? Starting from one point and ending indefinitely. That's right, EF. And what about this? You have G and you have H. So this is ray GH. Okay. This is nothing but a ray. Now, can you tell me the symbol for a line? What is it? For a line, what's the symbol? That's right. This is the symbol for a line because it extends indefinitely in both directions. What is the symbol for line segment? What's the symbol for line segment? That's right, because it's got a starting and an ending point. Very good. What about the symbol for a ray? Yes, very good. It has a starting point, but it extends indefinitely in one direction. That's why it is like this. All right. Now let's talk about an angle. What is an angle? Remember ray? We talked about ray. When two rays start from the same point, they form an angle. So let's take two rays. This is one ray, AB. Here is another ray, AC. As you can see, AB is a ray and AC is another ray. And both these rays are starting at what? At A. As you can see, they are starting at A. Therefore, they form an angle. This is an angle. This is the angle that is formed between both the rays. Alright. Now, how is an angle named? An angle is named with a single capital letter or three capital letters. Single capital letter, angle A, or three capital letters, B, A, C. Alright. So, this is read as angle A. And this is read as angle BAC. Alright. This is how we name an angle, either as a single letter or three capital letters. Alright. And it is read as angle A or angle BAC. Now, when two lines intersect, then also they form angles. Let's see. Let's look at two lines. These are two lines. You have AB and CD. Alright. As you can see, lines AB and CD, They are intersecting, and they are intersecting at a point called O. This is the point where they are intersecting. Sorry. Yeah, they are intersecting at this point called O. Alright. Now, can you see the angles that are formed? That's right. We have one angle here. You see? Another angle here. Another angle here. And another angle here. As you can see, there are 4 angles that are formed. So, the angles that are formed are angle COA. Angle COA is this one. Okay. Then angle AOD. As you can see, angle AOD is this one. And then we have angle DOB. DOB is this one. And finally we have angle BOC. BOC is this one. These are the angles that are formed when 2 lines intersect at a point O. Now, what are the parts of an angle? Okay. What are the parts of an angle? So, let's consider this. As you can see, we have 2 rays, QP and QR. And this is the angle that is formed. Alright. And here we have 2 more rays called OT and OP. As you can see, this is the angle that is formed. This is your figure 1 and this is your figure 2. Now, look at figure 1. The angle that is formed, what is the angle that is formed? Where is it formed? It is formed at Q. Okay, it is formed here. Alright, it's formed at Q. So, this Q is called the vertex. VERTEX, vertex. Alright, and QP and QR. QP and QR are the 2 arms. Alright, these are called the arms. Both QP and QR are called the arms. So we have the vertex, which is Q, and arms, which is QP and QR. They are the arms. Alright. Now what about figure 2? Can you guess what is the vertex there and what are the arms? That's right. The angle is formed at O. Right? Here's the angle that is formed. So O is the vertex. Perfect. And what about the arms? What are the arms? That's right. OP and OT. They are the 2 arms of the angle. Alright, this one. This is one arm and this is another arm. 2 arms of the angle. So these are the parts of an angle, vertex and arms. Alright, now let's look at naming of an angle. Naming of an angle. Okay, now let's consider this. This is EP is your ray and ET is your ray. When the 2 rays meet at one point, they have the same starting point E, they form an angle. This is the angle. Okay, now as you can see, there is only, how many angles are there here? There is only one angle and the angle is formed at E. Alright, now what is E called? That's right, it's called the vertex. Very good. Okay, so this angle can be named as, we will saw earlier, what can this angle be named as? This angle can be named as angle E, correct? And it is read as angle E. Alright, it is read as angle E. Or you can also name it as PET and it is read as angle PET. Alright, remember, always remember this, it's very important when you write PET. The vertex, what is the vertex? E, right? E has to be in the middle when we use 3 letters to name an angle. Alright? Alright, the vertex has to be in the middle when we use 3 letters. Since we are using 3 letters, the vertex has to be in the middle when you are naming the angle. Remember that. Let's consider another one. Let's look at this. As you can see, we have, this is A. AT is your one ray, AC is another ray, and AP is another ray. As you can see, there are how many angles that are formed? That's right, 3 angles. 1, 2 and 3. Alright. All the 3 angles are formed. Where is it formed? At A. That's right. So A is your vertex. Perfect. Very good. Alright. So because 3 angles are formed at A, at vertex A, they cannot be named by a single letter as angle A. You cannot do this because there are 3 angles formed at vertex A. Alright. So what do? We have to use 3 capital letters to name them. That's right. We have to use 3 capitals. So we cannot do it this way. We have to use 3 capital letters to name them. So let's see, how do we name the 3 angles? The first angle is angle CAP. Which is that? That's right. This is the one. You can see this is the angle that is formed between AC ray and AP ray. Alright, that is CAP. And remember, vertex A has to be at the center. Correct? Vertex A has to be at the center. So that's one angle, angle CAP. What is the next angle? Angle CAT. Excellent. Which is CAT? This is CAT. Alright, that's your second angle. And what's the last angle? Angle PAT, which is this. This is how you name the 3 angles. When there are 3 angles formed at the same vertex A. Alright, you cannot name it as A, angle A. You need to name it as 3. You need to name using 3 capital letters. And remember, in all these 3 angles, remember A is in the center. Okay, because A is the vertex. Alright, let's consider this. What if there are 4 angles? Okay, what if there are 4 angles? We've seen earlier. We've seen this. RS, yes, PQ. Okay, as you can see, there are 4 angles formed. 1, 2, 3, 4 at this point O. Okay, since 4 angles are formed at O, the vertex of all the angles is, what is the vertex? Vertex is O. Perfect. Very good. Alright. So obviously you cannot name all the 4 angles by a single letter O. You cannot say angle O. So you name the angles, all the 4 angles using the capital letters, all the 3 capital letters. Let's see how can we do that. So what are the 4 angles that are formed? How do you name them? You already denoted it. How do you name them? How do you name this? How do you name this? That's right. That is angle SOP. Okay. It can be either angle SOP or POS, but the important thing is the O has to be in the center because it is a vertex. Alright, so we are done with this angle. What about this angle? Perfect. That is angle QOS. And what about this angle? Very good. ROQ. And finally, what about this angle? Angle POR. This is how you name the 4 angles. Notice O is in the center of all the 4 angles because it is the vertex. Alright, have a look at this picture. This is your geometry box. Okay, most of you would have bought it when you bought the books in the beginning of the academic year. If you don't have a geometry box, it's good for you to buy one and keep, because we need to use this geometry box while learning geometry. Alright, now inside the geometry box, these are the instruments that you will find. First, you will find a compass. That's your compass. Then you will find a divider. Then there is something called a protractor. Then you have a set square. And then you have a ruler. Of course, there will be a pencil and an eraser and a sharpener also in some boxes, but these are the main instruments: compass, divider, protractor, set square and ruler. How to use each of these instruments we will soon learn. Alright, now let's see how you can measure line segments using a ruler. Remember, we saw the ruler in the geometry box. Now, if you take the ruler out, how can you actually measure the length of a line segment using a ruler? Okay, alright. Now, Have a look at this line segment AB. Alright. So to measure that line segment AB, what do? You need to keep the 0 mark. If you look at the ruler, can you see the 0 mark of the ruler? Can you notice the 0 mark of the ruler? Yes, you need to put that 0 mark of the ruler at A. That's the first thing you need to do, put it at A. Second thing is, place the ruler edge, that is the edge, along AB. It needs to be along AB. It cannot be slanting. It cannot be any other way. It has to be along AB. And then you read the measurement that coincides with B. Look at the measurement that coincides with B. Now, can you tell me what is the measurement of AB? The measurement of AB is 6 centimeters. That's right, it's in between 6 and 7. Because it is a centimeter scale, it's between 6 centimeter and 7 centimeter. So it is 6 centimeter and 5 millimeter, or it can also be written as 6.5 centimeter, and it is read as 6.5 centimeters. This is how you can measure line segment using a ruler. Once again, to measure the line segment, first thing is you keep the 0 mark of the ruler at A. You need to keep it as A. Then you place the ruler edge along the line segment AB. Then read the measurement that coincides with B. In this case, the measurement of AB is 6.5 centimeters. Alright? Okay. Now let's look at closed plane figures. Alright? You know what are closed plane figures called? They are called polygons. Okay, let's observe and learn some of the polygons. First, we are going to look at triangles. What is a triangle? What are some of the properties of a triangle? All of you know how a triangle looks. This is how a triangle looks. All right. All right. So P, Q, R. As you can see, a triangle has 3 sides or 3 line segments. I am going to denote that with these are the 3 sides or the 3 line segments. Can you see that? Alright. How many corners are there? That's right. It's got 3 corners. This is one corner, this is one corner, this is another corner. Okay, these corners are also called vertices. Alright. 3 vertices. And can you see how many angles it's formed? That's right. You can see the angles that are formed are also 3. 1, 2, 3. 3 angles. Okay. So you got 3 sides or 3 line segments. You got 3 corners and it's formed 3 angles. Now, can you see that the angles are named with capital letters PQR? That's right. Alright. So it's named with PQR. Now, how do you denote a triangle? A triangle is denoted as triangle PQR. That is how this triangle is denoted. Okay. And it's read as triangle PQR. Now, tell me what are the sides? What are the sides? Those marked in yellow. That's right. It's PQ. That is this one. QR. That is this one. And PR, that is this one, 3 sides. Alright, and what are the angles? What are the angles? We have angle, that's your angle P. You have angle Q. And you have angle R. Okay, you can also write these angles as what else? Angle QPR. Okay, that is this angle. QPR is going to be this angle because P is in the center. P is the vertex. That's why you have P in the center. And then you have angle PRQ and angle PQR. Okay. So that's another. This is PQR and this is PRQ. When you name the angles this way, always remember that the center, the vertex has to be at the center. Alright. Okay, now let's look at a square. We looked at a triangle, now let's look at a square. What's a square? Okay, this is your square. As you can see, a square has got 4 sides. Alright, it's got 4 sides or 4 line segments as denoted in green. How many corners has it got? It's got 4 corners or 4 angles or 4 vertices. Alright, let's write the corners as, let's name it as A, B, C, D. Alright, and how much can you also notice that all the 4 sides are equal? That's right, 4 sides are equal. Alright, and can you see that they are named with 4 capital letters? A, B, C, D. That's right. How do you denote a square? A square is denoted like this. Square A, B, C, D. Because we named it as A, B, C, D. It's denoted like this and it is read as square A, B, C, D. Now tell me, what are the sides of the square? Can you tell me? AB, very good. AB is this one. Sorry. AB is this one. And then you have BC, which is this one. Then you have this one, that is CD, and you have AD. Okay. Now, as we saw earlier, all 4 sides are equal. That means you can say AB is equal to BC is equal to CD is equal to AD. This is a very important property of a square, that all the sides are equal. Now, what about the angles? What are the angles? Yes, we have one angle here, one angle here, one angle here, one angle here. Okay, this is angle A, angle B, angle C, and angle D. Let's write that. What are the angles? Angle A, angle B, angle C, angle D. Or you can also write it as, remember, with the vertex at the center, angle DAB, which is this one, which is this one. Then you have angle ABC. Where is ABC? This one. That's right. And then you have angle BCD. What's BCD? Here. And you have the last one is angle CDA. Angle CDA. Now, remember, all the angles are also equal. That means angle A is equal to angle B is equal to angle C is equal to angle D is equal to, they are all 90 degrees. If you measure the angle, it is 90 degrees or it is a right angle. These are the properties of a square. Now let's look at a rectangle. Okay, rectangle has this shape. It's a closed polygon with this shape. Okay, now as you can see, of course this is not, I am not drawing with a ruler, so it is not exactly a rectangle, but approximately it looks like this. All right, so this is P, O, and M, N. All right, how many sides does the rectangle have? That's right, 4. 1, I'm going to mark it in green. 1, 2, 3, and 4. All right, now it's got 4 sides or 4 line segments. How many corners? Again, 4 corners. Very good. 1, 2, 3, 4, and the 4 angles are P, O, N, and M. All right, 4 corners or 4 angles or 4 vertices you can call. Now, unlike square, only the opposite sides are equal. That's why, can you see the 2 lines that are true green lines? MN, this side, this and this sides, these 2 sides are equal, and these and this, these 2 sides are equal. Only the 2 opposite sides are equal, and they are named by 4 capital letters. And how do you denote a rectangle? Just denote a rectangle like this. Draw a rectangle and MNOP, that is the name of this rectangle, and it is read as rectangle MNOP. All right, now tell me, what are the sides? What are the sides of this rectangle? Perfect. MN, NO, PO, and MP. Which is MN? MN is this, NO is this, PO is this, and MP is, and MP is this. These are the four sides of a rectangle. And what did we say? Tell me, what are the sides that are equal? We have MN is equal to the opposite side, PO. Okay, these two are sides are equal. MN is equal to PO, and we also have these two sides, that is PM will be equal to NO. Opposite sides are equal. Now what about the angles? What about the angles in the rectangle? As we know, there are four angles that are formed: angle P, angle M, angle N, and angle O. Or you can also write it as angle MPO, angle MNO, angle PON, angle PMN. Notice all the vertices at the center. Alright, basically these are the four angles: this, and this. Four angles that are formed. Now again, like a square, all the angles are equal. That means angle P is equal to angle M is equal to angle N is equal to angle O. All are equal, and they are 90 degrees. If you measure it, it's a right angle, 90 degrees. Okay, now let's look at the last polygon called a circle. All of us know how a circle looks. This is how a circle looks. Circles, as you can see, they have no line segments. All right, they have no line segments, they have no corners, they have no angles, but it has a center. This is called a center. Okay, now the outer curved line is called circumference. This one is called your circumference. Okay, now so the length of the outer boundary of a circle is called circumference. All right, now for a square or a rectangle, the length of the outer boundary, okay, that means the length of this whole boundary, the length of the outer boundary, the total outer boundary, if you measure the length, that is called a perimeter. In fact, for a triangle also, square, rectangle or triangle, the length of the outer boundary is called a perimeter. Okay, whereas the length of the outer boundary of a circle, okay, remember, it is called a circumference. So the length of outer boundary for square, rectangle and triangle is called perimeter, but the length of outer boundary of a circle is called circumference. Okay, now how do you actually find the perimeter? How do you find the perimeter? Let's have a look at a couple of examples. Now, all right, let's take this square A, B, C, D, and they have given you that the length of one side is 6 centimeter. All right, now how do you find the perimeter of the square ABCD? Square ABCD, how do you find the perimeter? Remember, the perimeter is what? The length of the outer boundary. So you just have to calculate the total length of the boundary. That is, the perimeter of a square is nothing but AB plus BC plus CD plus DA. This is how this forms your outer boundary, right? And because all the sides are equal, everything is 6. 6 plus 6 plus 6 plus 6. They've given you one side as 6 because all sides are equal in a square, everything is 6. And if you add that up, it will come to 24. So the perimeter of square ABCD is 24 centimeters. This is how you can calculate perimeter of a square. How about a triangle? Let's say this is your triangle. Okay, P, Q, R, and they've given the length of the sides as 5 centimeter, 6 centimeter, 4 centimeter. Now, can you guess how do you find the perimeter of the triangle? Perimeter of triangle PQR. That's right. You just have to add all the sides, PQ plus QR plus PR, because the perimeter is nothing but the length of the entire outer boundary of the triangle. So the outer boundary is PQ plus QR plus PR. So just add it up. 5 plus 4 plus 6. If you do the addition, you will get it as 15, and it's always centimeter. Don't forget to write the units, 15 centimeters. This is how you can find the perimeter of a triangle. Let's look at how you can find the perimeter of a rectangle. That's your rectangle FEF and CD. Okay, they've given you 7 centimeter. One side, if they've given you centimeter, you know that in a rectangle opposite sides are equal. So this is also 7 centimeter. And if this is given as 3 centimeter, you know that this side is also 3 centimeter. Remember, opposite sides are equal. Now, what is the perimeter of a rectangle? What do you think we should do? Perimeter of the rectangle CDEF. What do you do? That's right, just add up all the sides. That is FE plus ED plus DC plus CF. Okay, because the length of the entire outer boundary of the rectangle is the perimeter. So you just add up the entire, all the sides. So FE is 7 plus 3 plus 7 plus 3. Opposite sides are equal. Okay, remember, if you add this up, you get it as 20. And what do you write the units as? Centimeter. This is how you can find the perimeter of a square, rectangle or a triangle. Easy, right? Alright, now let's look at patterns. Okay, what are patterns? Shapes or figures that are arranged in definite order, repeated over and over again, makes a geometrical pattern. Okay, I want you to observe this. Let's take an example of this. Can you see? Can you notice a pattern? This is a shape that is arranged in a definite order, and if you have to continue the pattern, how will it be? It will continue it as same thing. It's repeated over and over again. This is a pattern. Okay, it can be any shape. It can be any shape, but it follows it is arranged in a definite order and it is repeated over and over again. Let's have a look at this. Can you have a look at the pattern? If I have to ask you to continue the pattern, what will it be? This way. This is your pattern. Goes on. Alright? Like that, any shape or any figure that is arranged in a definite order, repeated over and over again, forms a pattern. Alright? Now you can look around and observe various patterns around you. Alright? You can look at your curtains, you can look at your floor tiles, you can find it in your rangoli patterns. You'll observe that there are a lot of patterns, and you can observe those patterns and you can make a note of it, and you can make your own patterns and color them as well. Alright then, that brings us to the close of basic geometry chapter. I hope it has been fun and you have learned quite a bit. Now, there are a lot of questions given at the end of the chapter and at the end of every concept for you to practice, because when you practice, you become perfect. So please take time today and the rest of the days to practice as many questions as possible, and do feel free to watch the video again if you want to understand a certain concept, and also reach out to your parent or to your teacher if you have any doubts. So do your homework well, practice well, and I hope you become super good at geometry. Have a great day and see you soon.